Magical but true, how our universe is formed. 1. The singularity and the start of the universe. The universe began as a singularity, a point where density and temperature were infinite, and the conventional laws of physics broke down. This singularity wasn't in space or time, instead, it contained all of space and time. It's challenging to visualize because our everyday experiences don't include such extremes. Time itself began with the Big Bang, meaning there was no before in the conventional sense. 2. The Big Bang and cosmic inflation, 10 to the power of 4 cubed seconds after. The Big Bang isn't an explosion in space but an expansion of space itself. In the first Planck time, about 10 to the power of 4 cubed seconds, the four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were unified. The universe underwent cosmic inflation, a period of exponential expansion lasting a fraction of a second. During this time, the universe expanded faster than the speed of light. This doesn't violate relativity because space itself was expanding. Inflation smoothed out the universe, explaining why the cosmos appears uniform on large scales while still containing slight irregularities that led to galaxies. 3. The quark-gluon plasma, 10 to the power of 6 seconds after. As inflation ended, the universe was filled with an incredibly hot soup of quarks, the building blocks of protons and neutrons, and gluons, particles that mediate the strong nuclear force. Temperatures exceeded 10 to the power of 15 Kelvin, so energetic that particles couldn't bind together. As the universe cooled slightly, quarks combined into protons and neutrons through processes governed by the strong force. 4. Nucleosynthesis, 3 minutes after the Big Bang. About 3 minutes after the Big Bang, the temperature dropped to around 1 billion Kelvin, allowing protons and neutrons to form the first nuclei. Light elements such as hydrogen, helium, and trace amounts of lithium and beryllium were created in this process, called Big Bang nucleosynthesis. Heavier elements didn't form yet, they would later be synthesized in stars. 5. The universe becomes transparent, 380,000 years after. By this time, the universe had cooled to about 3000 Kelvin. Electrons and protons combined to form neutral hydrogen atoms in a process called recombination. With free electrons no longer scattering photons, light could travel freely through space, creating the cosmic microwave background, CMB, the afterglow of the Big Bang. This radiation is detectable today as faint microwave signals. The universe transitioned from being a hot, opaque plasma to a cool, transparent state. 6. Formation of the first stars, 100 to 200 million years after. Gravity caused small density fluctuations from inflation to grow, forming clumps of gas that collapsed into the first stars. These stars were massive and short-lived. Through nuclear fusion, they produced heavier elements like carbon, oxygen, and iron, which were scattered into space when the stars exploded in supernovae. 7. Galaxy formation, 1 billion years after. Groups of stars began forming galaxies, massive collections of stars, gas, dust, and dark matter bound by gravity. Galaxies started clustering together under gravity, forming large-scale structures like galaxy clusters and filaments that we observe today. 8. Our solar system, 9 billion years after the Big Bang. About 4.6 billion years ago, our Sun formed within a nebula, a cloud of gas and dust left over from previous star generations. The remaining material in the nebula coalesced into planets, moons, asteroids, and comets, forming the solar system. Earth, positioned in the habitable zone, developed conditions favorable for life. Deeper mysteries. What caused the Big Bang? While the Big Bang describes how the universe evolved from a hot, dense state, it doesn't explain why or how the singularity came to be. Several hypotheses explore this. Quantum fluctuations. In quantum physics, particles can spontaneously appear and disappear. Some theories suggest the universe emerged from a quantum fluctuation in a pre-existing vacuum or quantum field. The multiverse hypothesis. Our universe might be one of many universes within a larger, multiverse. Each universe could have different physical laws and constants. Cyclic universe models. Some theories propose the universe undergoes cycles of expansion and contraction, with the Big Bang being the start of the current cycle. Time begins with the Big Bang. If time itself began with the Big Bang, the question of before may be meaningless. This aligns with Stephen Hawking's no boundary proposal, which compares the universe to a sphere without edges. Open questions and future exploration. Dark matter and dark energy. We still don't fully understand the nature of these components, which together make up about 95% of the universe. Cosmic origins. What triggered inflation? What determines the physical laws we observe? Life in the universe. How did life arise, and is it unique to Earth, or is it common across the cosmos?